Solving rational equations. So a rational equation is when you have your fractions. So let's look at 12 over x equals 3. So in order to solve, we need to isolate our x, and then we can solve to get x equals. So to get x out of the denominator, let's multiply both sides by x, and that will give us 12 equals 3x. Divide both sides by 3, and we get x equals 4. Remember to consider your restrictions. In this case, for our domain, we could not have x equals 0. We got x equals 4, so we're okay. Let's try again. 3x over 10 plus 2/5 equals 4x minus 3 all over 5. So first thing I need is a common denominator. I have 10 right here, so if I could multiply this by 2, which means this by 2, and this by 2, which means this by 2, I could have a denominator of 10 the whole way across. So that will give us 3x plus 4 over 10 equals 2 times 4x is 8x, 2 times 3 is 6. Now if I multiply this side by 10 and this side by 10, these 10s and these 10s will cancel. And then we have 3x plus 4 equals 8x minus 6. So now we need to move all of our x terms to one side and all the numbers to the other. So let's move the 3x over here and the 6 over there. So that will give us 4 equals 8x minus 3x is 5x. Add the 6 to both sides. So we get x equaling 2. Remember to go back and check your domain. We did not have any restrictions in our denominators, so they're good. So x equals 2 is our final answer. Let's try again. 1 over t plus 3 plus 4 over t plus 5 equals 2 over t squared plus 8t plus 15. Well, in this case, we need to do some factoring so that we can see what we have, so we can see what we need as our common denominator. So let's factor this. I need two numbers that multiply to 15 and add to 8. So let's use t plus 3 and t plus 5. How convenient. That's what we had over here. So our common denominator, let's use t plus 3 times t plus 5. That means this piece needs a t plus 5. And this piece needs a t plus 3. Then we have our common denominator all the way across. So that will give us t plus 5 plus 4 times t is 4t, 4 times 3 is 12, all over t plus 5 times t plus 3 from our common denominator, equaling 2 all over t plus 5 times t plus 3. There we go. Now if we multiply both sides by our common denominator, this one and this one will cancel. And this one will cancel. Then we're left with t plus 4t is 5t, 12 plus 5 is 17, equaling 2. And then we can solve this down. So let's subtract our 17 from both sides. And we'll get t equals negative 3. So let's look at this for a second. T equals negative 3. Look back at the original question. In the denominator right here, we have t plus 3. So if I were to put negative 3 in for t, we're going to get 0 in the denominator here, and we're going to have division by 0. We cannot have division by 0. If we were to put the negative 3 here, same thing's going to happen, and we'll get division by 0. We can't have that. So mathematically speaking, while we solved and we got t equals negative 3 is not part of our domain. So that means we cannot have negative 3 as a solution. So this one has no solutions. Let's try again. So if we look for a common denominator, this one needs an x, this one needs a 4. So we need an x here and a 4 here. So that's going to give us x squared plus 20 over 4x equaling 3. So in order to get rid of this 4x right here, we need to multiply both sides by our 4x. Then this will cancel. So now we have x squared plus 20 equals 12x. So let's solve this down. Move your 12x over. So we need two numbers that multiply to 20 and add to negative 12. So how about x minus 2 and x minus 10? So that tells us that x minus 2 could equal 0, or x minus 10 could equal 0. So x is equaling 2 and x is equaling 10. So let's look back at our domain. We had just an x in the denominator to begin with, so our restrictions would be we could not have 0. So we have 2 and we have 10, so we have a valid solution. So the solution here is x equals 2 and x equals 10. Another way to solve rational equations is by cross multiplying. So let me show you an example of that. Let's say we have a plus 2 over 7 and a minus 3 over 2. So cross multiplying is your favorite part of an equation because you get to cross your whole thing out. So you draw a big X right here through the equal sign. You pretend that you have parentheses. There we go. And then you multiply the pieces that are on the same ends of the X. So for example, this line right here is connecting the 7 and the a minus 3. So that's going to give us 7 times a minus 3. This line right here is connecting the 2 and the a plus 2. So 2 and a plus 2. You can only do this when you have one fraction and one fraction. If you had multiple fractions, you'd have to clean it up first. But if you have one fraction and one fraction, you can cross multiply to solve. So distributing our 7, we get 7a minus 21. Distributing our 2, we get 2a plus 4. And then we can solve it down like normal. We can subtract our 2a from both sides. We can add our 21 to both sides. And then we can divide both by 5 on both sides, and we get a equaling 5. Looking back at our original equation, we did not have any restrictions because we just had a 7 and a 2 in the denominator, so we're okay. Let's look at one more. So say that you're given f of x equals 3x minus 5 over x, and you want to find the values of x that make f of x equal negative 14. So what that means is, see if you can find where f of x is going to be negative 14. So in other words, negative 14 equals 3x minus 5 over x. So we want f of x to equal negative 14. Notice it is not telling us that x is negative 14. If it wanted to say x was negative 14, it would look like this. This isn't what we have. So we are not putting negative 14 in the value of x. So let's solve this down. Well, the first thing that we're going to need to do over here is clean this up some. So right now this is over 1. So if I wanted a common denominator, I can multiply by x and by x. So that will give us negative 14 equals 3x squared minus 5 all over x. Multiplying by x on this side, multiplying by x on this side, these will cancel, and we have negative 14x equals 3x squared minus 5. Let's move the 14x over so we can have 0. And now we need to factor. You can use your AC method or your guess and check, any method that you would like. This will factor to x plus 5 and 3x minus 1. So x plus 5 equals 0 and 3x minus 1 equals 0. So here we're left with x equals negative 5. Here if we add the 1 and divide by 3, we'll be left with x equals 1/3. So let's look back at our original. We had just an x in the denominator in the original, so negative 5 and positive 1/3 look like valid solutions.